welcome to the show. I'm Nick Romico. Today we're with Ryan Chivers, and he's from Artisano Natural Plasters, and Mark Schoeneman. He's the Executive Director of the Colorado Straw Bale Association. We're also rejoined by Kenton Shepard. He's Nachi TV's green building expert. Boys, what are we doing here today? We're in a barn or what?
No, we're in a straw bale home. And behind Mark here is a pallet wall. Mark, you want to tell us a little bit about this pallet wall?
Yeah, well, I guess it's in keeping with my mission statement to try and do natural products in the home and do recycled products. And, you know, these are pallets that I've collected over time. And when it came time to building, we just stacked them up and scabbed in some 2x4s to hold them steady, stapled them, nailed them to the top and bottom, filled them with straw clay. And what it does is it provides some insulation inside, some sound barrier, and also some mass. So as you can see, we've got a lot of windows here, more than what you should have on the south side. So the idea is that the room warms up and heats up this instead of heating you up. And so at nighttime, when the sun goes down, you close the drapes, and this heat that's in here radiates back out into the house.
So will the straw alone provide the thermal mass, or what will be on the outside of this as the wall covering?
We will be plastering these walls, and in keeping with my mission statement to use natural products, we're going to be plastering with a natural plaster, which is Ryan's field. He can tell you a little bit about that, but we're going to put a little netting over here and just plaster it. And when we're done, you shouldn't know that it's a pallet wall. This is sort of the before and after shot. This is very before. You should have seen it before we got the straw on it. It looks really weird. It looked like a cattle yard.
So it looks a little uneven because the pallet pieces are different thicknesses. So how thick will the plaster be?
Well, because it's uneven, you know, as you can, well, lath and plaster. You know, the old lath and plaster. The lath was all flat, but there were holes, you know, so you've got some parts that are going to be 2 inches deep, and we hope to get the outside about 1 inch. So if you've got varying sizes of your wood, but when we're done, it's all going to be flat.
Mm-hmm. Can we see an outside wall?
You may.
Let's go. Okay, so this is an exterior wall. It looks pretty thick. How thick is it?
Well, we have options. The bales on this house are laid flat, which means the strands of the straw is oriented in this direction, and so it's 18 inches thick without the plaster. You can turn them on edge, giving you the same R value. The strands, of course, run this direction, and the wall would only be 14 inches thick.
Now, how do you run wiring through here and plumbing?
Well, this house is a little bit unique, but you can run them right through the bales as you're putting the bales up. This is a unique house because we have a ICF foundation, which is insulated concrete form, and there's a brick ledge form that goes in that shape to set brick on, and then your wall would normally sit here. Well, we have, with this shape here, we run the wires inside this channel, and then up the wall and up where we have framing members, which there's framing members virtually only at the doors and windows, and that's what supports the box beam, which is this 2 LVLs with a piece of OSB on the bottom.
Now, what about building permits and building inspectors? Do they have trouble with this type of construction?
Well, you know, in some areas you might have trouble with that. In the Boulder area, we have, actually when I went for my site plan review, which is they review everything you're trying to accomplish with your building, I told them I was doing straw bale. It was on the prints, and they said, oh, we want people like you, because they're sort of green, not sort of, they are green oriented.
So Ryan, don't you have to put some sort of chicken wire or lath on here before you plaster it?
That would be the conventional idea, and that's how they do it a lot with, you know, of course, cement stucco. The reason that they do that is for some kind of mechanical bond. Normally you're stuccoing over plywood. In this instance, the straw is a very rough surface, and the earthen plaster wants to stick right to it. What we do is we put a coat of pure clay that we spray on the wall, and if you can see, we have an extremely rough surface that sort of is all kind of stuck together. And then we come with our subsequent coats of earth plaster, which is clay, sand, and straw. So typically we don't put any reinforcing mesh on the bulk of the wall. You can see here we have reinforcing mesh around these corners because the straw bales actually end right here at the wood. And then this is just stuffed with loose straw, so we have to have something that holds all that straw together. But we do put some type of reinforcing mesh anytime we're connecting straw bale across wood, because whenever you have dissimilar materials, you want to have some sort of a bridge that prevents cracking at that junction.
Now, Mark, what about bugs and rodents? Don't they just love this stuff?
Well, they would if they were stacked up outside without plaster on them. But once they get the plaster on them, it's really tough for them to get in. And once they get in, it's straw. It's not hay, so there's no seed products in here. There's nothing for them to eat. And, you know, it's the old phone book thing. You can tear through a page easily, but try and get through a bale that's tightly baled, tightly twined together. There's nothing for them to do. They're going to look for the path of least resistance, and it's not going to be with 1.5 inches of plaster, earth or stucco, and then a tight bale.
Now, what about fire? Isn't this prone to catching on fire?
Well, we'll go back to the phone book thing. You know, tear a page off a phone book and light it. It lights very easily, but try and light the phone book. You have the same thing. If you had a lot of loose straw laying around, it could be a problem. And that's why on a daily basis, when we're stacking bales and chainsawing bales and carving bales, we pick up all the loose straw and save them for these pallet walls or for in our mud mix.
So the risk is during construction. The risk of it catching on fire is mostly during construction. After it's all plastered over, we're okay.
Well, we're as okay as any other conventional building, and maybe a little bit more so. They've done some tests, some engineers, and they just did them this summer. And a stuccoed wall passed the 2-hour test, an earth plastered wall, and keeping in mind they only did 3/4 inch of earth plaster, whereas generally speaking you do 1 inch to 1.5 inches, passed the 1-hour test. And what that means is once the fire starts on the inside, you have an hour before it ever shows any kind of sign of burning through on the other side. And actually the fire test is a pretty dramatic film that they have on the ecologicalbuildingnetwork.com, I believe. And they have the film of this 10 by 10 huge structure of gas that is flaming, and they pull it up to a wall that they had built, and they get it progressively higher until they reach 1,760 degrees, flat against the wall. And after 1 hour, they saw a little smoke going through the other side because the wall had a crack in it. And so then they pull the fire membrane or the fire source off and hose it down to see if they can push a hole through with the high pressure water, and it couldn't. So that's how they got the 1-hour rating. The cement stucco wall passed a 2-hour rating. So they're pretty fire resistant once they get plastered.
Now, what about the straw? Doesn't it settle after a while and cause a heat loss at the top of the wall?
A standard conventional insulation, as an Owens Corning or cellulose, would probably settle.
Cellulose especially.
Cellulose especially. You know, they overshoot. You know, you want an R38, they give you 14 inches, knowing that R38 is 12 inches, knowing that you're going to get 2 inches of settling after that. But now, the straw has, first of all, we compress them into place. So they're very tight to begin with. But then once we put the plaster on, the plaster's holding the bales up. There's an integral bond between the straw and the plaster, so it's not going to settle.
It's actually attached to the back of the plaster.
It's attached to the back of the plaster. It's on both sides and supported by the floor and supported by your foundation. So it's not going to settle. So you're not going to have any air gaps.
Mark, with all this straw, it looks like a giant sponge. Aren't you worried about water getting into the walls?
I'm very worried about water getting into the walls. You do not want water in the walls. So there's several avenues that you take to minimize the potential for water getting into the walls. One is you have big overhangs. It's very important to have a good hat and good boots is what you'll hear in the straw bale world. So the good hat is big overhangs. You know, in our latitude, you want 2-foot overhangs minimum or optimum for the south-facing walls, so that you don't get any sun into the house in the summer, and when the sun lowers its orbit in the winter, you get a full sun. So on the rest of the house, I've got 3-foot overhangs. 6 is optimum, but you know, in any of the rains that we've had so far, the walls haven't been touched. Now you get driving rains, and driving rains can be a problem. But once you get the walls plastered, the rains hit the plaster and not the inside of the bales. And that's the most important thing. What you don't want to have happen is for water to get to the inside of the bales. Now, I can see water here, and I can see water on the outside because the plasters will change colors. And if I've got a problem, then I deal with it. But when it gets to the inside of the wall, I can't see it. And when you put the bales up, I should add that the maximum moisture content that you want in your bales is 20%.
And you test that with a meter?
And you test that with a moisture meter. There's actually a probe that goes in and a digital readout, and if it's 20%, reject the bale. And you can reject the bale just knowing, you know, what the average bale feels like. We put 500 bales into this. Average bale is like this, and then all of a sudden there's one that's really heavy. Well, either it's got a lot of rocks in it, or it's moist. So you save that for your mixing them with your plaster, stuffing in your pallet walls, and then you can actually physically see it once you pull the twine apart.
Do you do anything particular about flashing the doors and windows?
Yes, and that's there's a million different ways of flashing doors and windows, and it's basically your conventional flashing method. So whatever you use conventionally for flashing, that's it. The frames of the windows are my supports. So I've got a wood frame around the whole structure. So you've got that metal flange that comes on the windows. Screw it in and do your ice and water shield as you normally do. You know, it's not anything different than you would do in a normal construction method.
That keeps the windows to the outside of the wall also, so the water tends to drip down the plaster instead of sitting on a sill.
That's right, and you're not exposing. Well, on the back of the house, I did a window that sits on the inside of the bale, and we did a metal pan on the bottom, and did some ice and water shield on underneath that, and we're putting flagstone on top of that, and plus it's got a huge overhang. So, you know, if water ever gets in there, it's not going to be much, and it's not going to get to the middle of the bale. It would really have to work at it. Now, the other thing that we try and keep water, moisture out of the structure is doing a toe-up, or your good boots. And the good boots is, on the outside, I have 18 inches of stone, so my foundation actually goes up another 18 inches from my slab-on grade, and so that eliminates any splashback from rains from the roof.
It's also good for bugs, too.
It's also good for bugs, yeah. Well, bugs can crawl. They have legs, so they can get up higher. But, you know, you flash that, and, you know, I run around with a hammer in one tool belt and some caulk in the other tool belt. And, you know, that's the other way moisture gets in and out of the building is vapor. You know, you have people taking showers, you're cooking pasta, just humidity from bodies. You know, you have a party, people spill beer, you get moisture inside, and it wants to get outside. So if you have some negative pressure in the house, or I guess maybe it's positive pressure, it's going to want to push out. So you want to conventional framing is the same way. You want to seal all holes. You know, the new building science is that you build it tight and vent it right. So you create no not negative or positive pressure in the house. And that's a building science. That goes with any kind of house you want to build.
Now, I understand you have some sort of system by which you can check the moisture content of walls even after you plaster it.
That's right. We have been
built that in.
Yeah, we built that in, and it's pretty cool, you know. And when I was asked, there's a fellow that makes these things, and he said, "Do you want me to make some of these?" And I thought, you know, where are we going to put them? There's 500 bales. We're not going to put them in for 500 bales. So you pick the most likely place to get moisture. As in, you know, there might be one. I'm not even sure. I don't remember where they are, but I've got it written down. You know, you put one in here, down on the floor, where you might get moisture leaking in the roof up below your box beam.
And you run wires back to a panel where you can test it later?
And you run wires back to a panel that you can test with a little moisture meter. And there's a little block of wood on the outside, on the inside, and in the middle. And your moisture meter has two prongs, and you hit the middle prong, which is the negative, and then you hit the outside middle, and you can see where your moisture
Can we go see the
is.
panel?
Sure.
All right, let's go. Back to building it tight and venting it right, we have an HRV system installed in this house.
Yep.
And this is that moisture panel you told me about, where I see it's all labeled.
we have labeling so we don't forget where we have all the moisture meters. And what you do with the moisture meter is got two prongs, and they're just little nails, and you put one in the center, and you go to the outside sensor, to the sensor in the middle of the bale, and then the sensor on the inside of the bale. And so if you have a problem, you can tell exactly where the moisture is, so you can go right to that point. You know, you can do just physical observation. You know, if you have an earth plaster or even a cement plaster, you'll see a darkened spot and you'll know that there's moisture. But this helps you get inside. You know, the moisture spot might not show up on the outside plaster if it's in the middle of the bale.
And you've put these probes, you've built them into places where you suspect would have a great chance of maybe moisture or something?
The most likely place where you have water wicking from the foundation, or next to a window where you have vapors permeating to the outside, or underneath an eave where you might have a leak in the roof, or down by the foundation where you might get driving rains or splashback.
And is it just a regular protometer, moisture meter that you use on
It's
this?
a regular moisture meter, but what's irregular about these things, and it's pretty cool, it's just, there's several different methods. The method we used, the fellow took just a plastic paint bucket and cut strips,
right,
and put little squares of wood outside, middle, and the other end, and then put telephone wire to it, and then ran them to this area and labeled everything. And now, you know, I feel pretty confident I've tested all of these, and I have one place that the moisture is a little bit high. And if it stays high for any length of time, I'm just going to go cut the bale out. And it's a long story why that happened, but we sort of pre-dipped some bales, to make it a short story. We pre-dipped some bales because they were going to go in behind some plywood. And somebody probably dipped the bale and went and had lunch. And I'm thinking that's probably why.
Well, it'll make a great test for your system.
Yeah, that's right. That's exactly right. And so it's the moisture's been going down. So the ideal thing is that you don't have continued moisture for any length of time.
That's awesome.
Yes.
Now on the HRV system, how does it all work?
It's a pretty simple system. We have air coming from the outside, which is the black tube over there, and it comes in up here. And it goes through this box, which mixes the air and comes out in this direction and hits this pipe and vents to the inside. So that's the fresh air. Now the stale air is coming from the kitchen area and comes in this pipe, goes through this way, and leaves the heat, 80% of the heat, with the incoming air, and vents that stale air to the outside through this pipe over here. So what you're doing is you've created this airtight house. And picture this. You have a bunch of people over. Some are taking showers. You're cooking pasta. People are drinking wine and beer. There's lots of moisture in the house.
You're making me hungry.
And I'm hungry myself. Let's go. And so and then you have your fireplace burning. So your fireplace is drawing air from the inside of the house, and it's pushing the air outside, but your fireplace isn't vented or doesn't get the outside air feed. It's
right,
creating a negative pressure in the house. So what you're having is you're asking air to be driven into the house, and you don't want that. So what you want to do is not have your house negatively pressured. So that's what this is doing. You've got inside air going outside and outside air going inside, so there's no negative pressure or positive pressure inside the house.
Excellent.
Yeah. And it recovers the heat, so it's not as though you're sending all the heat out the door.
And you don't smell the pasta all over the house.
And you don't smell, well, yeah. you want to smell that.
I'm with Mike Hamner. He's from Longs Peak Piping, and he put in this underfloor radiant system, am I right?
That's right.
A lot of zones here.
Yeah, this is actually a medium-sized system. There's 7 zones here, and some of them have as many as 15 or 20, but this is average size.
Now, as an inspector, I know a lot of times we see some cross connections where the antifreeze could be sucked up into the domestic water supply. How do you keep that from happening?
Well, yeah, you're right. You have antifreeze on the floor, and it might get sucked up into the domestic water system, and that's what this device is. This is a backwater check valve, and that keeps the water from going back into the domestic water, city water. And that's what an inspector will usually look for, that and a low water cutoff, which is inside the boiler.
And that's the boiler right there?
This is the condensing boiler right here.
And what fire is it, propane?
That's propane, yes. And it's state-of-the-art condensing boiler. It's Triangle Tube is the company name, and it actually uses the flue gases to take some of the heat out of the flue gases to preheat the water is what it does.
It's almost like being turbocharged.
Yeah, and it's 94% efficient, which is about 40% more over the old traditional type boilers.
I see the plastic flue above
Yeah,
us.
it's got plastic flue. That's because the flue gases are so cool, because it does use the heat from the flue to preheat the water.
Thanks, Mike.
Bet.
This might throw a few home inspectors. There's two big tanks here, and they are for storing water to supply the fire suppression system throughout the house. That system, along with these two tanks of water, gives the owner of this house a $200 discount on his insurance policy. So he's only paying $300 a year to insure this whole house. One of the reasons the owner had this installed is because this particular home is far from the city and far from any fire department. Mark, what do we have going here? Big Lego blocks or what?
Well, they're kind of like Lego blocks, a little more natural though. They're adobe blocks, which is what Anastasi built with thousands of years ago. And the basic ingredient is dirt and sand and clay and straw, just sort of to hold it together.
Doesn't sound like expensive ingredients.
They came from right outside.
And you formed it yourself?
Formed it ourselves out of 2x6s. You can form any size. We have some 4x4 in the other room. These are 8x6 by a foot long.
And what are you doing? Building an interior wall here with it?
I'm building an interior wall, and it serves several purposes. One is I want to put a couch. It's basically going to go a foot away. I
Right.
put them close enough. They're heavy enough that I don't want to have to move them very far. I want to put a couch right here, and so that gives some place for the couch to sit. But more importantly is you can see where the sun is hitting this right now. The summer solstice is in, what, a week or 2 weeks?
Right.
And so this is as tall as the wall is going to be, plus a couple inches of mortar, which the mortar, by the way, is the same as this. The plaster is going to be dirt, and so I get passive solar gain where the sun hits this, heats it up all day, and at nighttime radiates that heat.
So
back
you're
out.
using it to collect heat.
It's free heat, man. It comes from the sun. I think it's a great thing.
Now it won't look like this. You'll plaster it?
It'll get plastered. Yeah, we'll put a couple coats of plaster on it, just like we will. Basically, everything will get plastered in the same way. And then the finish coats we can do. We use a white clay and silica sand and casein, which is a milk protein, as the binder, and we will basically be able to create any color that we want and any texture.
So Ron, you'll be able to make this wall in color?
Absolutely. Yeah, we use natural pigments, iron oxides and ochres and stuff like that.
And what if I scratch the wall? Will the color be all the way through?
The color's all the way through the finish coat.
That's excellent.
So,
And it feels so much better than just drywall.
yeah, a plastered wall definitely feels way better than like a latex painted drywall wall. It's got kind of an aliveness that if you go to Italy or you go to some of these buildings that are hundreds and hundreds of years old that are all plastered, they just have a kind of a thing.
This home has a soul.
That has a soul, yep. And the color's never perfectly flat in the exact same color, and there's texture and the way that the light plays on it and everything. So it's really, from an aesthetic standpoint, it's amazing if you compare it to a latex painted wall.
We wanted to show you what a finished home looks like, so we ran over to a house that's already completed. Ryan, it's beautiful. Can you tell me about it?
Well, Nick, these are straw bale walls that are finished. They are basically the exact same system that we had in the other house. Straw, one coat of earth plaster, and a finish coat of gypsum plaster. And then the color, you can see it's kind of an off-white, which is a subtle color, comes from a lime wash, which is a paint that's made from lime and water that people have been using for 9,000 or 10,000 years. And it's got a little bit of natural ochre pigment in it to make the color. And
Get real deep window seal again.
yeah, because the straw bale walls are so thick, you get these big round window returns that really play on the light and make just a really beautiful wall. And you can see that the wall is definitely anything but perfectly flat, which also adds to the character of the walls and makes them very beautiful, in my opinion.
I'm with the architect on this project, Brian Fuentes from Fuentes Design. Now, straw, it doesn't sound like a very high-performance building material. How does straw bale construction compare to high-performance building systems?
Well, it's one of the high-performance building systems that are being used today for super-insulated homes, and it's very comparable in terms of its resistance to thermal heat flow, or R value, which is the common denominator for wall systems. It has high thermal mass as well, so it's very heavy. So like the ocean in the winter, it stays warm a little longer into the winter because it has so much mass. The straw bale plaster is the same way. It's 1.5 inches of plaster on the inside and outside, and so that helps modulate the temperature as well. Some of the other building performance systems that you might see are super insulated stick frame walls where they have foam insulation and then also a foam wrap on the outside of rigid foam. They're also using double stick walls with blown-in cellulose or foam. Also insulated concrete forms, which are basically styrofoam, which is a brand name, but and then there's concrete infill, and that has a really high embodied energy. So one of the reasons to use straw bale is that it has a very low embodied energy. So in order to trap that heat, it has lots of little air pockets contained in the straw, in the cellulose material itself. And so those, every time you move from a material to air, you're getting a little bit of R value, a little resistance to flow of heat, and so that's what keeps it warm on the inside and cold on the outside in the winter. And so that's the same strategy that's used in styrofoam, lots of little air bubbles in between the foam pieces, which might be in a structurally insulated panel or an insulated concrete form or in a spray foam application. So it's the same principle, but in a natural, local, low-embodied material that's been used for centuries in buildings all over the world.
Well, the home you designed is absolutely beautiful.
Oh, thanks
you. Thanks for being on the show.
Yeah, appreciate it.
We're in the kitchen of the home here, and what you see here are supply pipes for the kitchen sink. They're coming out of the floor, and the drain is going into the floor, the waistline, because typically in straw bale homes you do not want to put any supply lines in the straw bale walls. If you have to, and occasionally you do, you want to sleeve them in waterproof PVC, making sure that all the joints are sealed. Sometimes, and this house is no exception, there's a cavity beneath the wall. Supply lines can be run in there if they can't be run under the floor for some reason.
We're on the outside of the house now. Kenton, tell us a little bit about moisture and mold. Do we have some worries here?
Well, you don't want moisture to get into the house, but if it does, into the straw, but if it does, the nice thing about straw is that it will hold a lot of moisture before it approaches the 20% level at which mold fungi become active. That's mold decay fungi.
All right, Ryan, we can't really plaster this at this time of the year yet. You have to wait till spring?
Yeah, now that it's wintertime, we won't put any plaster on the outside of the house because the plaster can't at any point freeze while it's wet. Otherwise, it'll ruin the exterior.
And it looks like you have a light layer already on here just for protection.
We were able to get this layer on before the freeze came, and this will keep us through the winter. Just able to keep the walls from getting too wet. But you can see here we have huge overhangs too. So for the most part, there's not really going to be any water getting onto these walls because of good design.
Mark, what about the cost compared to conventional construction? Is this expensive?
The cost can be very similar, and actually can be a lot less or a lot more depending on who you hire or if you do some of the work yourself. I like to think that effort and dollars equal your home, and if you put a little more effort, it's going to be less dollars. If you've got a lot of money, you want to hire people, it's going to cost a little bit more. Certainly, there's other there's other factors. You have kitchens, you have appliances. You could upgrade everything that goes with
all those are
a straw bale house or a conventional house. But what I like to think of cost is environmental cost, because I've worked construction all my life. For 36 years, I poured concrete, and I've seen dumpsters get taken away from jobs worth of materials that were just called scrap, and I've dumpster dove for 2x4s and materials that get thrown away, and it's sad really that we use up that much resource and don't value that resource.
So a lot less cost to the environment.
A lot less cost to the environment. You got straw, which is a waste product. It's what's left over after they harvest the grains, barley, wheat, oats, rice. We've got stone that came from digging the foundation. The adobe block inside
dirt
is dirt. I mean, that came from digging the foundation.
Pallets.
Virtually. Pallets were something that were going to be thrown away. I have a tree that fell down in my front yard last year. It's on the other side of the house, and I had that milled up, and those are going to be my 18-inch wide window seats. So, we have to think environmentally. We don't have endless resources of fuel, and we just need to use products that have environmentally friendly base. And
Now, this is a healthy home too, am I right?
it's a healthy home. There's no VOCs. You know, it's not perfect. You can see up here we have some foam, and you know, someone once said, "Don't let perfect stand in the way of good." So we've got a great home, super insulated. It's not going to cost that much to heat.
Healthy to live in.
Healthy to live in.
And now, is the pasta organic?
My pasta is.
Mark, thanks for being on the show.
My pleasure, Nick.
Ryan, thank you.
Nick.
Kenton, once again, thanks a lot.
You bet.
And we'll see you next time.